Good morning, students. Welcome to the class of mathematics. So today we will do some numerical based upon rotational mechanics. So here we have taken one selected numerical where a string is wrapped around a wheel of r equal to 20 centimeter. Okay. So here the wheel which we have marked into the green color. Okay. This wheel is wrapped with a string. So this is blue string is just rotated about it. Okay. This is rotated about this wheel like this. Okay. So when we just pull it from a force, that is force given here is 20 Newton. Okay. Force equal to 20 Newton given. So what will be the torque? First we will understand what is the torque. When we identify the torque, then as per the moment of inertia, torque equal to I alpha, we'll calculate the angular acceleration. From the angular acceleration, we'll use the formula theta equal to theta 0, omega equal to omega 0 plus alpha t. As in single dimension for the linear equation we have used, v equal to u plus at. Then we calculate the value. So let us find it out. Okay. So here you can see the string is wrapped around wheel of r equal to 20 centimeter. Okay. The wheel's radius is r equal to 20 centimeter, or we can convert it into meter. So that 20 by 100 is equal to 0.2 meter. So r equal to 0.2 meter, right? Now torque generated. What is the torque? Torque is equal to force which is applied from a distance, that is r. Okay. R is the radius of wheel, because the wheel is attached with its axis, and the axis is at which point? Axis is at this point. Okay. You can see the yellow horizontal vertical bars are attached with this one. Okay. So this is the axis. So I'm marking it is an axis. So we'll just pull it from a string tied from this blue colored string. Then if with a force of 20 Newton, then torque will be equal to 20 Newton, this force, okay, into radius. Radius is equal to 0.2 meter. Okay, that is equal to 0.2 meter, and the torque will be equal to 4 Newton meter. Okay, this is the torque. Now we have calculated the torque. We have calculated the torque. We have calculated the torque. Now what we'll find? We'll find. We also know that torque is equal to torque. This generated torque equal to I alpha. Alpha is the angular acceleration. Alpha is the angular acceleration. And I is the moment of inertia. Moment of inertia. Right. So we'll use the formula here. We have calculated the torque. So what will be the alpha? We'll get it from here. Okay. How we'll do it? Let us see. Putting the value as torque equal to I alpha implies torque equal to 4 Newton meter equal to I. I is a moment of inertia. What is that? I is we can take it from the numerical. From the question is moment of inertia is 0.20 meter. I here 0.20. So kg per square meter. So this will be 0.20 kg per square meter. So I will be 0.20 kg per meter square into alpha. So we'll calculate alpha, the angular acceleration as 0. No, sorry. We'll just calculate it. 4 alpha in the LHS, 4 Newton meter will be divided by 0.20 kg per meter square, and when we'll cut it, we'll getting it as 400 by 20, and that is equal to 20. So alpha, that is angular acceleration, is equal to 20. Angular acceleration equal to 20 radian per second square, right? Will be equal to 20 radian per second square. 20 radian per second square. Okay. Now we'll use the formula. So we need to identify the velocity, angular velocity at 5 seconds. Okay. We are knowing the equation for the rotational mechanics, that omega equal to omega 0 plus alpha t, where omega is equal to angular velocity, which we need to identify. So angular velocity is equal to omega 0. Omega 0 means angular velocity at rest. Okay. Angular velocity at rest. Okay. This one omega 0, which will be equal to 0. This will be plus alpha. Alpha is 20 into time. Time is given as 5 seconds. Okay. 5 seconds. You can see the time is given as 5 seconds here. This one. So now what we will get, omega, the angular velocity, is equal to 100. So omega, that is angular velocity, equal to 100 radian per second. Okay. Hope you got the concept behind this, students, how we have solved this, and how to solve such questions going forward. You are getting this concept. Okay. So omega equal to 100 radian per second is the value which we calculate from this. Okay. So now we'll write it out. This is the value. Now we'll go and angular velocity omega. We'll write it out here. Omega equal to 100. So omega equal to 100 radian per second is our answer. So we have solved this question, students. So for any query, just put up into the comment box and just keep on learning. You will succeed someday. And I will always say subscribe to my channel, and happy learning. Keep on learning. Thanks. Bye bye.